1943. At the Guidonia airfield near Rome, the heat rising from the tarmac was a physical presence, a suffocating blanket draped over a nation at war. For Italy's most brilliant aeronautical engineer, Filippo Zapata, this day would not just be hot. It would be a crucible, one that would burn away every illusion he held about his country's chances for victory. Before him sat a prize beyond calculation, a technological treasure delivered not by spies or commandos, but by a simple, mundane mistake in navigation. It was an American fighter plane, a Lockheed P-38G Lightning, captured almost perfectly intact after an emergency landing in Sardinia. To the Italian pilots who gathered in the shade of the hangars, their confident swagger a stark contrast to the machine's bizarre appearance. The aircraft was an ugly joke. They called it Il Diavolo a Due Code, the two-tailed devil. The name was meant as a taunt, a dismissal of its clumsy, awkward form. It was a violation of every principle of sleek, beautiful Italian design philosophy. It looked less like a thoroughbred and more like a beast of burden. But Filippo Zapata was not a pilot. He was an engineer. He dealt not in aesthetics, but in the brutal, unforgiving mathematics of performance. And as he began his methodical examination, walking a slow, deliberate circle around the gleaming machine, he felt the first prickle of a terrifying premonition. He was about to uncover a prophecy, written not in scripture, but in aluminum and steel. This was not a mere aircraft. It was the mathematical proof that Italy had already lost the war, a war its leaders still believed was winnable. Zapata was a giant in his field, the senior propulsion engineer for the Regia Aeronautica, a man who had dedicated his life to the symphony of the internal combustion engine. He had dissected captured British Spitfires, marveling at their Rolls-Royce Merlin engines. He had studied the secrets of the German Messerschmitts, respecting their efficiency and power. He believed he knew the precise balance of power in the skies over Europe. In a few short hours, he was about to discover he knew nothing at all. As his team of the finest engineers in Italy approached, their toolboxes rattling, a strange sense of dread settled over him. The Americans hadn't just built this machine. They had built it in such numbers that they could afford to send it thousands of miles across a hostile ocean to fight. That fact alone spoke of an industrial capacity so vast it bordered on the fantastical. But the true horror, the technological secret that would shatter the morale of an entire nation's engineering corps, lay hidden from view, sealed beneath its two enormous engine cowlings. They weren't just falling behind in a technological race. They were standing at the starting line of a race that their enemy had already finished, taken a victory lap, and gone home. The P-38 Lightning was the physical embodiment of everything Italian engineering was not, where Italian masters crafted elegant, lightweight fighters like the Machi C-202, pieces of flying art designed to wring every last ounce of performance from scarce resources. The Lightning was an American monster. It was massive, complex, and powered by a technology so advanced, it might as well have been from another world. On paper, the specifications Zapata had reviewed seemed almost absurd, a list of luxuries that screamed of wastefulness and unnecessary complexity. 2 Allison V1710 engines where one should suffice, experimental turbochargers, complicated counter-rotating propellers, a tricycle landing gear which seemed needlessly heavy. It was a checklist of typical American excess, but Zapata was a scientist, and a scientist trusts only one thing: the data. The time for reputation and rumor was over. The time for measurement had begun. The first hour was spent on the most basic of tasks, the kind of work reserved for apprentices. Yet every senior engineer participated in a tense silence. They were simply documenting its external dimensions. The wingspan was 52 feet, nothing particularly unusual for a twin-engine aircraft. But then came the weight. Using structural analysis, fuel capacity data, and load-bearing calculations on the landing gear, they computed the aircraft's fully loaded mass. The number that emerged from the slide rules was staggering, a figure so outlandish that they checked their calculations twice. Nearly 18,000 pounds. Zapata's young assistant, Giorgio Mancini, a prodigy from the University of Bologna, looked up from his notepad, his voice a disbelieving whisper. 18,000 pounds? Capo, that's impossible. That's nearly twice the weight of the Machi C-202. It weighs more than some of our light bombers. He stared at the colossal machine, at its thick wings and deep fuselage. How does something this heavy even fly like a fighter? Zapata stared back at the P-38, his expression grim, the sweat on his brow suddenly cold. That, he said, his voice low, is the question that should frighten us all. And we are about to find the answer. He already suspected that the answer would be deeply, profoundly unsettling. The age of elegant, nimble dogfighters was over. A new age, an age of brutal, overwhelming industrial power, had begun. And this was its harbinger. The real autopsy began. With a screech of straining metal, his team of mechanics used their pry bars to pop the latches and swing open the huge cowling panels on the portside engine. And as the gleaming heart of the Allison V-1710 was revealed, bathed in the harsh Mediterranean sun, the world seemed to stop. The entire team of veteran engineers, men who had seen every engine Italy and Germany had to offer, fell into a profound, unnerving silence. It wasn't its size, though the 12-cylinder liquid-cooled V-configuration engine was a beast by their standards, filling the entire nacelle. It wasn't even the flawless, almost artistic quality of the machining on every visible surface, a level of precision their own factories, starved of high-grade steel and shattered by relentless Allied bombing, could only dream of achieving. It was something else, something they had only read about in fragmented, almost mythical intelligence reports, a technology their own scientists had dismissed as too complex, too unreliable, and too expensive for a mass-production fighter. It was the turbocharger system. Zapata had seen the German experiments with this technology. He had personally reviewed the Italian proposals drawn up years earlier. The theory was beautifully simple. Use the wasted energy of hot exhaust gases to spin a turbine, which in turn would drive a compressor to force dense, pressurized air into the engine's intake. It would allow an engine to maintain its sea-level power at crushing altitudes where the air is thin and conventional engines gasp and choke. Every major power knew the theory, but no one, not the brilliant Germans, not the resourceful British, and certainly not the cash-strapped Italians, had managed to solve the immense engineering challenges. The metallurgy required to withstand the heat, the precision balancing of the turbine, the complexity of the control systems. It was a nightmare, a problem for the future. The Americans hadn't just solved it. They had perfected it. They had engineered it for mass production. And they had put 2 of them on a single aircraft. And, according to the latest intelligence, they were building hundreds of these aircraft every single month. Zapata reached out a trembling hand, his fingers tracing the intricate network of insulated exhaust ducting that snaked through the tail boom toward the turbine assembly. He leaned in, his face inches from the turbine wheel itself. It was a masterpiece of metallurgy, a perfectly forged component of some unknown, exotic alloy, engineered to withstand forces that defied belief, spinning at over 21,000 revolutions per minute, all while being blasted by corrosive exhaust gases hotter than 700 degrees Celsius. It shouldn't have been possible. What alloy is this? Mancini breathed, his voice filled with a mixture of an engineer's awe and a competitor's dread. Zapata shook his head slowly, his eyes never leaving the turbine's futuristic blades. Nickel chromium, perhaps, or something proprietary we have never encountered. A cobalt steel alloy? Whatever it is, we don't have it. We cannot make it. And even if we could steal the formula from a laboratory, we lack the forges, the smelters, and the precision casting facilities to manufacture a single one. The implications of that simple, brutal fact were a dagger to the heart of the entire Italian war industry. Each of the P-38's engines, thanks to this impossible piece of engineering, could generate over 1,425 horsepower in an emergency. That was a combined total of over 2,050 horsepower. He did the math in his head. The brand-new Daimler-Benz DB605 engine, the absolute pride of German engineering that powered Italy's most advanced fighter, the brand-new Machi C205V, produced a mere 1,475 horsepower. A single American P-38, an aircraft they had laughed at just hours before, had nearly double the engine power of Italy's absolute best fighter. It wasn't just a step ahead. It was a generational leap, a quantum jump in technology that left them hopelessly behind. The numbers only grew worse, more damning with every component they examined. Zapata began to mentally calculate the vast industrial and engineering chain required to create such an engine. The Allison V1710 displaced 28 liters. It required the perfect, flawless machining of 12 massive cylinders, 12 pistons, intricate connecting rods, and a crankshaft forged from steel so pure and strong it could endure 3,000 revolutions per minute under the brutal, fluctuating stress of combat. Then you had to add the supercharger, the turbocharger, the intercooler to cool the compressed air, the oil cooling system, the massive radiator, the complex reduction gearing. The list was endless. He pulled out his worn leather notebook, his hand beginning to sketch out the interconnected systems, the sheer complexity of it all. His assistant watched, his face pale, the earlier confidence of the morning now replaced by a chilling comprehension. He finally voiced the question that hung in the silent, heavy air. "Capo, could we build this?" Zapata didn't look up from his frantic sketching. He continued writing for a full minute, the scratching of his pencil the only sound against the distant hum of the airfield. Finally, he capped his pencil, looked up, and his eyes, weary and defeated, locked with his assistant's. Build one. Giorgio, perhaps. Given 6 months, unlimited resources, taking every one of our finest machinists from Fiat and Alfa Romeo, working in a perfect laboratory, shielded from the war. Yes, I believe we could build a single, fragile prototype that would likely tear itself apart on the test bench. He paused, letting the weight of his words sink in. But build it reliably? To build it in numbers? To equip our Air Force with hundreds of them a month? Impossible. It is simply, mathematically, impossible. The cooling system alone was a work of genius, a testament to an entirely different school of thought in aeronautical design. The Allison engine was liquid-cooled, a common enough technology, but its implementation was revolutionary. The radiators were not bulky blocks mounted under the engine, creating drag and a massive, vulnerable target. Instead, they were mounted remotely in the leading edges of the inner wings, forming a seamless part of the airfoil. This was a design choice of incredible sophistication, one that minimized aerodynamic drag while maximizing the massive airflow from the propellers. The radiators themselves were a marvel of manufacturing, not the chunky, heavy cores Italian factories produced, but intricate honeycombs of hundreds of tiny, precision-manufactured tubes, each one brazed with exact tolerances to prevent leaks under the extreme pressures and temperatures of high-altitude combat. Italian radiator technology was years behind, producing heavier, less efficient units that were notoriously vulnerable to a single stray bullet. The American design was a fortress. Zapata's team found that the system even integrated armor plating and redundant coolant passages. It was built with the explicit assumption that it would be shot at, engineered not just to perform, but to survive. It was built to take a hit and keep flying, to bring its pilot home. Mancini traced the intricate path of the coolant lines with a single finger, his awe palpable. "They've solved problems," he murmured, "that we didn't even know existed." Zapata corrected him, his voice grim and low, the words carrying the weight of a dawning, terrible clarity. "No, Giorgio. They have solved the problems we knew existed, but could never afford to address. We build for perfection on the drawing board. They build for the brutal reality of the battlefield. And then there were the propellers. They were counter-rotating. The left engine spun its massive propeller clockwise, the right spun its counterclockwise. To a pilot, this was an elegant, almost magical solution. It completely eliminated the powerful engine torque that plagued every high-performance single-engine fighter, a force that constantly tried to twist the aircraft through the sky and required constant rudder correction. This made the P-38 a remarkably stable, placid gun platform, allowing for unnervingly accurate fire. But for an engineer, this elegance created a manufacturing nightmare of the highest order. It required two entirely different sets of planetary reduction gearing, perfect, intricate mirror images of each other. It demanded separate propeller governors, sophisticated hydraulic systems, and a flawless synchronization mechanism to keep the two engines from tearing the airframe apart. Zapata called over his metallurgy specialist, Domenico Russo, a man who could identify the origin of a steel sample simply by the ring it made when struck. Russo was tasked with examining the reduction gearing, the precise, hardened assembly that converted the engine's ferocious 3,000 RPM into devastating, controllable power at the propeller shaft. Russo spent a long time in silence, peering at the components through a jeweler's loupe. Finally, he straightened up, took a deep breath, and shook his head with an air of finality. "We couldn't make these gears," he said flatly, his voice devoid of emotion. "It is not possible. Not with our current steel quality, not with our heat treatment furnaces. The carbon and chromium content here, it's beyond our capabilities." He tapped one of the gears with his pen. "These are designed to transmit 1,500 horsepower, day after day, without failing. Our best gears, the ones in the DB605, would strip themselves to pieces under half that sustained load." As the long, hot afternoon wore on, a broader pattern began to emerge. It was a pattern that Zapata found far more disturbing than any single piece of advanced technology. It was not just a difference in capability. It was a fundamental difference in philosophy. The American philosophy of design. Every system on the P-38 was engineered with redundancy, maintainability, and brutal battlefield survivability as its core principles. Italian design, born of necessity, was about maximizing performance from minimal material. American design was about achieving overwhelming performance through superior materials and manufacturing, and then adding layers of protection on top of that. Where an Italian designer would use one hydraulic pump, the P-38 had two. Where an Italian plane had one generator, the Lightning had two. It was a design ethos born from a nation that did not have to count the cost of every gram of aluminum or every pint of hydraulic fluid. The electrical system was the first proof. It used a 24-volt architecture, more powerful and robust than the 12-volt systems common in European aircraft. It was powered by two completely independent engine-driven generators. If one engine was knocked out by enemy fire, if one generator failed, the other could seamlessly take over and power every essential system on the aircraft: the radios, the instruments, the lights, the gun chargers. Italian fighters used fragile 12-volt systems with a single generator. One failure, one lucky shot, and the pilot could be left flying blind and deaf. Next, they traced the hydraulic lines. The P-38's massive landing gear, its large flaps, and its dive brakes were all hydraulically actuated. The system was powered by, again, redundant engine-driven pumps. The lines themselves were armored, wrapped in a protective shielding to resist shrapnel. The system was filled with multiple check valves and circuit breakers so that a leak in one area, for instance, a damaged landing gear line, wouldn't bleed the entire system dry and leave the pilot without flaps. Italian fighters often relied on manual cables for their controls, or simple single-point hydraulic systems that were notoriously vulnerable. A single severed line could mean the pilot would have to belly land the aircraft if he survived at all. Then they inspected the fuel system. The massive wing tanks were not just simple aluminum boxes. They were self-sealing, lined with a type of rubber that would swell and plug holes from machine gun fire, a technology Italy was only just beginning to implement in a crude and often ineffective form. But the Americans had taken it a step further. The tanks were interconnected by a complex cross-feed system, allowing the pilot to transfer fuel from one side of the aircraft to the other, balancing the load or feeding both engines from a single wing if the other was damaged. It even allowed the pilot to shut down one engine entirely for long range. Economical cruising, a odd feature so foreign to the Italian mindset of short-range interception that it seemed like something from a science fiction novel. But it was the ammunition capacity that delivered. The final, shocking, soul-crushing blow to the Italian engineers. After hours of analyzing systems designed for resilience and endurance, they finally moved to the front of the central nacelle, to the part of the aircraft designed for pure destruction. They opened the bay doors to the armament compartment. What they found there silenced them completely. The entire arsenal of the P-38 was concentrated in the nose. This in itself was a huge advantage, eliminating the need for wing-mounted guns to be harmonized to a single convergence point. The P-38's pilot simply pointed the nose at the enemy, and everything in front of him would be shredded. And the volume of that fire was beyond anything they had ever imagined. The aircraft carried a 20mm Hispano cannon, with a drum containing 150 rounds of high-explosive shells, and packed around it were 4 Browning M2 50-caliber heavy machine guns, each fed by an ammunition box containing 500 rounds. A full 2,000 rounds of 50-caliber ammunition, plus the cannon shells. Mancini did a quick calculation on his notepad. "Capo," he said, his voice cracking. "This is 3 times the ammunition load of the Machi C-205V. 3 times." He stared into the ammunition bay, at the perfectly ordered belts of gleaming brass cartridges. "They built a flying battleship," he whispered. He pointed to a small electric motor integrated into each feed chute. "Look at this. An ammunition boost motor. It ensures the guns feed perfectly, even when the pilot is pulling 6 Gs in a negative G maneuver. Our guns would jam solid under those conditions." By late afternoon, Zapata was taking notes furiously, but he had stopped writing down technical specifications hours ago. His calculations had shifted from engineering to something far bleaker. He was now estimating production requirements. He figured each P-38 required approximately 50,000 individual, perfectly manufactured parts. Each of its 2 engines contained over 6,000 components. The electrical system, he estimated, used over 8 miles of complex wiring. The hydraulic system required hundreds of precision valves and high-pressure seals that Italian suppliers simply could not produce reliably. The very aluminum of the airframe was made from advanced alloys that Italy, suffering from Allied naval blockades, was struggling to obtain in even the smallest quantities. He finally put down his pencil and looked up from his notebook, his gaze falling upon the 2-tailed devil that sat gleaming under the setting Roman sun. And, for the first time in his long and decorated career, a career built on pride in Italian ingenuity and craftsmanship, Filippo Zapata felt a cold, profound, and utterly complete despair. This wasn't just an enemy aircraft. It was a messenger from a different world, a world with unlimited resources, with factories that ran 24 hours a day, with a workforce that could churn out metallurgical masterpieces by the tens of thousands. It was evidence of an industrial revolution that had left his entire nation, his entire continent, in the dust. This P-38 wasn't just a weapon, it was the future. And it was a future in which Italy had no place. The war would not be won by brave pilots or clever designers. It would be won by the nation with the most factories, the most resources, the most engineers. It would be won by mathematics. And the math was now terrifyingly, undeniably clear. Of course, here is the 3rd full-length 20-minute chunk of the script. This section moves from the static analysis to the dramatic flight test, where the cold numbers are translated into terrifying reality. That evening, Filippo Zapata sat alone in his stark office at Guidonia, the single lamp on his desk casting long shadows across the walls. He began writing his report. The technical specifications filled 12 pages, a dry, emotionless litany of measurements, component analyses, materials assessments, and performance calculations. It was a document of pure engineering fact. But it was the final section, a section he titled Strategic Assessment, that he knew would be seen as controversial, even treasonous. With a steady hand, he wrote the words that had been haunting him since he first looked upon the Allison engine's turbocharger. He wrote, "The Lockheed P-38. Lightning represents a level of aeronautical engineering sophistication that exceeds current Italian manufacturing capabilities by a margin of approximately 5 to 7 years at our current rate of national development. More significantly, the aircraft demonstrates an American industrial capacity operating at a scale that we cannot comprehend, let alone match." He detailed his specific findings, laying them out like a prosecutor building an irrefutable case. The Allison V1710 turbocharged engine produces power nearly equivalent to our most powerful engines at sea level, but with vastly superior performance at high altitude due to its turbocharging. Italian industry lacks the metallurgy, the precision machining, and the quality control to replicate this engine. Production of a single prototype would require an estimated 18 months and would exhaust the resources needed for 20 conventional fighters. He continued, his pen scratching in the quiet office. The turbocharger system alone represents a technology beyond our current capabilities. The materials science, the precision casting, and the high-temperature metallurgy required are not available in Italian industry. The counter-rotating propeller system, while effective, requires precision reduction gearing we cannot manufacture reliably. The airframe construction demonstrates aluminum alloy quality and forming techniques superior to our current standards. Finally, he summarized the American philosophy. The system's integration, electrical, hydraulic, fuel, and armament, shows a design philosophy that prioritizes redundancy and battlefield maintainability over simple weight savings. This approach is only possible for a nation with engines powerful enough to overcome the inherent weight penalty. American manufacturing appears capable of producing these complex aircraft in enormous numbers while maintaining impeccable quality standards. Intelligence reports suggest production rates exceeding 200 of these aircraft per month from multiple factories. For comparison, total Italian fighter production across all types currently averages 150 aircraft per month, and this rate is declining due to material shortages and constant Allied bombing. He paused before writing his final damning recommendation. The P-38 cannot be countered through direct technological parity. Existing and developmental Italian fighters lack the engine power, altitude performance, and firepower to engage this aircraft effectively on its own terms. Tactical doctrine should be immediately revised to emphasize avoiding engagement with P-38s whenever possible, especially at high altitude. And then, the strategic conclusion. If this aircraft is representative of typical American production capability, and all intelligence suggests that it is, then Italy faces an enemy with an overwhelming, insurmountable industrial superiority. This war cannot be won through attrition against an opponent capable of producing weapons of this sophistication at this scale. Zapata read his report 3 times, checking every number, every word. He knew what would happen. The technical sections would be praised and distributed. The strategic assessment, the truth of it all, would be dismissed as defeatist pessimism, the ramblings of an engineer who did not understand the fighting spirit of the Italian pilot. But he was a man bound by evidence and mathematics, and the evidence was undeniable sitting on his tarmac. He signed the report and sealed the envelope. The next morning, Colonel Angelo Tandy, the Regia Aeronautica's chief test pilot, arrived at Guidonia to fly the captured Lightning. Tandy was a legend, a veteran with thousands of hours in dozens of aircraft types. He had flown every Italian fighter ever built, captured British Spitfires, even a German Messerschmitt Bf 109. He was the embodiment of the Italian fighting spirit Zapata's superiors held so dear. He listened to Zapata's technical briefing with a mask of professional courtesy, but his expression betrayed his skepticism. He believed in the skill of the man, not the brute force of the machine. Americans built heavy, clumsy aircraft. Everyone knew that. Quantity over quality. Brute force over elegance. He clearly believed the engineer was overstating things. With the confidence of a man who had mastered every aircraft he had ever touched, Tandy climbed into the P-38's surprisingly spacious cockpit. Zapata watched from the control tower, his report sitting on the desk, its conclusions still hanging in the air, waiting for the final human validation. He watched as the Lightning's engines started, not with the coughing roar of an Italian engine, but with a smooth, synchronized rumble that vibrated the tower windows. First the left, then the right. Tandy taxied to the runway, his movements cautious as he familiarized himself with the alien tricycle landing gear and the nose wheel steering. To the observers on the ground, used to Italian fighters that seemed to leap off the runway in seconds, the takeoff roll seemed impossibly long, ponderous, and heavy. The aircraft just ate up the tarmac, refusing to fly. The pilots watching began to smirk. But then, when the Lightning finally did rotate, it did not simply climb. It clawed its way into the sky at an angle so steep, so aggressive, that it made Zapata's breath catch in his throat. It was the angle of a machine with a monstrous surplus of power. 15 minutes later, Tandy landed. He taxied back to the hard stand and shut down the powerful engines. The silence that followed was profound. He just sat there in the cockpit for several long minutes, a lone figure in the canopy, staring at the instruments. When he finally climbed down the ladder and his boots touched the ground, his expression had changed completely. The swagger was gone. The easy confidence was gone. In its place was a look of quiet, sober shock. He walked directly to Zapata, ignoring the ground crew, pulling off his leather gloves. "Everything," Tandy said, his voice quiet but firm. "Everything in your report is correct." He paused, looking back at the silent aircraft as if it were a creature from another planet. "And you understated some things." Zapata simply waited for him to continue. "At altitude," Tandy explained, "this aircraft is untouchable. At 25,000 feet, it was still accelerating. It was still climbing. The climb rate exceeds anything I have ever experienced, anything we have. The control harmony is excellent. It's heavy, yes, but it is precise. The visibility from the cockpit is outstanding. And the firepower—" He stopped, shaking his head slowly. "I fired a test burst over the sea. Filippo. It was like unleashing thunder. The cannon and the 4 machine guns, all firing straight from the nose, with no convergence issues. You simply point the aircraft at the target and pull the trigger. Everything in front of it dies. There is no escape." Zapata nodded slowly, a grim satisfaction in his heart. His numbers had been right. "So, Colonel, can we counter it?" Tandy was silent for a long moment, his gaze fixed on the distant horizon. "Not with anything we have now," he said finally. "Not with anything we are developing. The Machi C-205V is an excellent fighter at medium altitude. The Fiat G55 has good firepower, but neither can match this American fighter in the regime where modern air combat is decided. High altitude, high speed, sustained operations. They will always be above us. They will always be faster." He turned to face Zapata fully. "And you are certain they are producing these at scale?" "Intelligence estimates 500 per month by the end of this year, 1943, Zapata replied. Tandy let out a short, harsh laugh, but there was no humor in it. 500 of these per month. We produce what? 50 Machis and 30 Fiats in a good month? And this is just one of their fighters. They are producing B-17s and B-24s by the thousands, P-47s, P-51s, ships, tanks, trucks, everything. He looked back at the P-38, a symbol of this terrifying new reality. We are fighting a nation that can afford to put two 1,400 horsepower, turbocharged engines in a single fighter aircraft, and then build thousands of them. What does that tell you about the future of this war? Zapata had no answer. The question was rhetorical. The answer was already written in his report, and now it was proven in the sky above them. Over the following weeks, the captured P-38 was subjected to every test the Regia Aeronautica could devise. They flew it in mock combat against their best fighters at every conceivable altitude and speed. They measured its performance in climbs, dives, and sustained turns. They compared its systems, piece by piece, against their equivalent Italian and German aircraft. Every single test, every single data point, confirmed the same devastating conclusion that Zapata had reached from his initial inspection. The Lightning was superior in almost every measurable way. At altitudes above 20,000 feet, the domain of the heavy bombers, nothing in the entire Italian or even German inventory could consistently catch it. The turbochargers, that miracle of metallurgy, maintained the Allison engine's full power, where Italian and German engines gasped for air. Even the formidable German Messerschmitt Bf 109G, with its advanced Daimler-Benz engine, began to lose significant performance above 25,000 feet. For the P-38, that was where it hit its stride. Its speed advantage at that height was absolute, allowing its pilots to choose when to engage and when to simply escape, pushing their throttles forward and vanishing into the deep blue of the stratosphere. The armament concentration in the nose proved devastatingly effective in mock gunnery trials. Italian fighters, with their wing-mounted guns, suffered from convergence issues. Their guns were typically harmonized to have their streams of fire cross at a single point, perhaps 300 meters out, but were far less effective at any other range. The P-38's nose-mounted weapons had no such limitation. They created a single, concentrated storm of lead that traveled in a straight line, shredding anything it touched. It was a simple, brutal, point-and-shoot solution. But what truly disturbed the Italian engineers was what they found when they began carefully disassembling individual components for detailed laboratory analysis. The build quality was extraordinary, almost inhuman in its perfection. Welds were flawless. Machining was precise to 1,000th of an inch. Materials were of the highest grade throughout. There were no shortcuts, no compromises, no evidence of resource constraints or rushed production. An Italian engineer examining the engine's piston rods wrote in his private notes, "Every component appears overbuilt to a safety margin we cannot afford." Where our design philosophy maximizes performance from minimal materials, the American design achieves overwhelming performance through superior materials and manufacturing. We build our machines to the very edge of what is possible. They build with margins that assume some components will fail, and yet the aircraft will still fly home. This philosophy was woven into the very bones of the aircraft. The structural members of the wings and booms were heavier than strictly necessary, providing a level of durability and battle damage tolerance that was unheard of. The electrical system was so laden with circuit breakers and redundant wiring that it seemed almost paranoid. The hydraulic lines were armored. It was engineering from a nation with unlimited resources. And it worked. The P-38's legendary toughness was no accident. It was designed in from the very beginning. Zapata's report, with its terrifying conclusions, climbed the chain of command. As he predicted, the technical sections were eagerly distributed to Italian aircraft manufacturers, with instructions to identify any relevant technologies that could be reverse-engineered for future implementation. An impossible task. The strategic assessment, however, reached the desk of Marshal Rino Corso Fuggier, the chief of the Italian Air Force. Fuggier read it carefully then filed it away. There was nothing to be done. He was a commander, not a magician. Italy lacked the industrial capacity to replicate American technology. German support was focused on their own desperate programs. The best Italian engineers could do was to continue to optimize their existing designs and hope that the courage and skill of their pilots could overcome a material disadvantage that was now proven to be a chasm. It would not be enough. In the quiet corridors of power, everyone knew it. But in a nation at war, it was a truth that nobody could say publicly. On August 11, 1943, Colonel Tandy was given the opportunity to fly the captured Lightning in actual combat. Intelligence had reported a formation of American B-24 Liberator bombers returning from a raid on Terni. Tandy took off from Guidonia, climbed to an altitude no Italian fighter could reach so quickly, and positioned himself above and behind the bomber stream. Using the Lightning's familiar silhouette to close the distance undetected, he singled out a straggling bomber. He opened fire. The concentrated firepower of the 20mm cannon and 4 heavy machine guns tore into the Liberator with shocking violence. The bomber faltered, broke from formation, and began its long fall to the earth. It was a small, symbolic victory. A single captured American fighter, flown by Italy's best test pilot, had destroyed 1 American bomber. For propaganda purposes, it was a useful story. For strategic purposes, it was utterly, completely meaningless. The Lightning was grounded shortly thereafter, without spare parts, without the specific American tools, without the detailed maintenance manuals, without the vast logistical support network that kept thousands of American P-38s flying around the globe. The captured aircraft became a useless curiosity, a hangar queen. Tandy never flew it in combat again. The war moved on. Italy surrendered to the Allies in September 1943. The Lightning at Guidonia fell into German hands, who also studied it, before it was eventually destroyed in an Allied bombing raid to prevent recapture. Zapata's report, however, survived in the archives, a quiet, technical document marking the precise moment when the engineers of a fading empire confronted the full, terrifying measure of American industrial might and found themselves powerless to respond. After the war, when the production figures from all nations were declassified, the true scale of the disparity was finally revealed. Zapata's worst fears, his most pessimistic estimates, proved to have been conservative. The United States produced a total of 10,037 P-38 Lightnings of all variants. Each one of those aircraft required 2 Allison V1710 engines. That's over 20,000 of one of the most complex engines in the world, just for the Lightning program alone. But the Allison V1710 was also used in the P-40 Warhawk, the P-39 Era Cobra, and the P-63 King Cobra. The total production run of this single engine type exceeded 70,000 units, Italy's entire wartime production of all aircraft engines, across all types and all manufacturers, was approximately 13,000 units. America had produced more than 5 times as many engines of a single advanced type as Italy had produced in total. The disparity extended to every category of industrial warfare. America produced over 300,000 aircraft during the war. Italy produced approximately $11,000. American aluminum production in the year 1943 alone exceeded Italy's total wartime output. American factory workers, many of them women who had never worked in manufacturing before, assembled these complex aircraft with a level of precision and quality control that Italy's finest craftsmen, with generations of experience, struggled to match. Years later, in the quiet of the 1960s, an Italian aviation historian interviewed an elderly Filippo Zapata about his examination of the captured P-38. The engineer, long retired and reflective, spoke carefully, the memory of that June day in 1943 still vivid. "I knew we would lose the war the moment I opened those engine cowlings," Zapata said, his voice frail but certain. Not because of any single component, not because of the turbocharger or the gears, but because of what the entire aircraft represented. The Americans had built a fighter that required 50,000 individual parts, including two of the most complex engines in existence, and they were producing them in quantities we couldn't match with our simplest designs. When I calculated the man-hours, the raw materials, the precision machining, the quality control required for just one of those planes, it was clear we were not fighting a nation. We were fighting an industrial giant that had barely begun to mobilize. He shook his head. The P-38 wasn't even their best fighter by the end. It was just one of several advanced types they were producing simultaneously by the thousands. While we struggled to build 100 fighters a month, they were building thousands, all of them as good or better than our best designs. Did you ever fly in it? The historian asked. Zapata smiled a faint, sad smile. No, Colonel Tandy offered, but I declined. I am an engineer, not a pilot, but I did not need to fly it. The numbers told me everything I needed to know. Power-to-weight ratio, wing loading, thrust available versus thrust required. The mathematics of flight performance are unforgiving. The P-38 had superior power, superior altitude performance, superior firepower, superior range, and superior systems. It was better. And there were thousands of them. That is a mathematical equation with only one possible answer. The captured P-38G at Guidonia never saw extensive service. It flew a handful of test flights, participated in one brief combat mission, and then sat in a hangar as a technological ghost, evidence of a war that was already lost, analyzed by engineers who understood the devastating implications, but were powerless to change the outcome. The story of the captured Lightning is ultimately a story about the mathematics of modern warfare. Italy entered the Second World War with excellent aircraft designers, legendarily skilled pilots, and a proud aviation tradition. But they lacked the industrial infrastructure to compete. They lacked the resources to develop advanced technologies like practical turbochargers. They lacked the materials to build with American safety margins. And they lacked the time to close a technological gap that widened with each passing month. Filippo Zapata's report documented this reality in precise, undeniable engineering terms. 2 Allison engines, turbochargers, counter-rotating propellers, concentrated armament, and behind it all, an industrial machine capable of producing these weapons at a rate that made Italian production seem insignificant. The captured P-38 sat on that Guidonia tarmac for only a few short months. But for the Italian engineers who examined it, who measured its components and calculated its implications, that single aircraft represented a turning point. It was the moment when mathematical reality overwhelmed tactical optimism, and they understood, with chilling certainty, that this war would be decided not by courage or skill, but by factories, resources, and industrial capacity. America had all three in abundance. The Lightning was proof, and no amount of Italian engineering genius could ever change that fact.